inductor. This is capacitor, this is inductor, the same thing. Physically it looks like this. Capacitor is like this, yeah? And inductor like this. So this is the wire winding that makes inductor, yeah? And this capacitor. So here it is actually
Ingatkan aku tau. Oh,
it is equal to CB, the relation, yeah? This is the charge accumulation. Here is I equal to L. Sorry. di by dt. The B. Here is B equal to I and di by dt. Here I
Nak pen kau?
I is equal to C dV by dt. You think that this is time variant, this is time variant. So the voltage across inductor VL is actually varying with the inductor value itself and the change in current with time. While capacitor current with the same parameter capacitor value and change in voltage with time. So one thing is changing voltage with time, another is changing current with time. This is the main difference, yeah? Because I don't know, you are the chemical engineer, you don't have the force like electromagnetics, yeah? The electromagnetics, if you learn, then you can understand that the current variation with time, actually current related to the magnetic field. And that has to say with the inductive property of the material. I think you study before entering the university. Have you studied Lenz's law? Faraday's law, yeah? This is related. Then the electrostatic, the Coulomb law or Gauss's law, that relation is there. The variation of voltage is actually charge, voltage, all the related to magnetic field. The variation of voltage is time. Think that both are time variant. That means there must have a time variant energy required. Time variant energy means actually it is alternating current. Oh, is Rosa called here? So how I can get it? So the thing is, it's no problem because how can I display? Broken. No turn on, no power. It is very common in Malaysia. People write
Yeah, rosak.
everything out of danger. Yeah? No responsibility. Yeah? You just write rosak.
Yes.
Everything responsible is the So okay, I think that is the thing. Actually, we just explore no problem. So this one understand. This is a fundamental thing you need to learn properly. Then the thing is actually, you know that before we talk about the resistance circuit, yeah? So the resistance, say this is the current, and this is the voltage. So think that current and voltage, that is the drop voltage, yeah? Not supply voltage. I am talking about some drop voltage, current. That is voltage why it is higher than current because you know the drop here equal to IR, yeah? So that R multiplication can make it bigger. It even depends on the resistance value, it can get higher. This is only magnitude, not direction, yeah? It is actually, you see that this is the thing, that is the same directional value of this voltage and current. It is actually DC with the resistance value, yeah? Or AC with the resistance value. DC, AC both, yeah? Because it has only the magnitude. But how about the AC? Whenever we talk about that, this is the AC circuit that we have, say resistance, say inductance. Then what will be the property? Say this is inductance, this is resistance. So do you think that the current flow here should be same phase with the resistance and inductor? Because it is time variant current. So Vs equal to V M sin omega t or cos omega t, whatever it is, yeah? So this current actually flows through the circuit. So here is the resistance, here is the inductance. So the thing is, inductance property is actually determined by you know that we actually think about the A value, the inductance value. Actually, it is supposed to be a pure inductive reactance 2 pi XL. Yeah. Sorry, 2 pi XL. 2 pi is the omega. Yeah. Omega, and this is the F is actually F. It means that the frequency actually 2 pi F is actually omega, and this part is omega. Yeah?
Harus ada hadiah.
So think that this inductance value and the angular frequency value determine its what? It is actually capable inductive reactance. The inductive reactance is actually determined by the frequency of the signal, because here it is omega is here. Think that the supply omega is there. Omega means 2 pi f. So it is frequency involved. So this frequency is here. So think that the reactance of the inductance should be XL equal to 2 pi FL. So this is dependent on frequency. So think that if the frequency increase, the inductive reactance will be increase. So think that if inductive reactance increase, then it will control the current, because if increase, then what direction it should be. So Lenz's law, what is actually Lenz's law determined? The voltage level. Say this is the reference voltage level. Say this is the reference voltage level B. Then current should be, before current and voltage was the same direction. Whenever it was only this, no inductance, yeah. On the resistive circuit, current and voltage should be same direction. But whenever you introduce the, sorry, it is the problem. You cannot relate this. So whenever you introduce the inductance, then it is no more same direction. What should be the direction now? You cannot write it. So what will be the problem? The direction. So think that this is the voltage direction. Now the current here through the inductance should be leading or lagging. Lenz's law what says? Any change you can make reverse. Yeah. So changing voltage, it can induce reverse current. Yeah? So think that the reverse current means it's actually 180 out of phase. So this direction is leading. Yeah. So this direction is lagging. So it will be, the inductive current should be lagging, reference to the voltage. Reference to the voltage, you know the 4 coordinate. Yeah. The coordinate is this. This is the J equal to 0, J equal to 1, J square equal to -1, J cube equal to -J. Yeah, this is the coordinate. So think that here B is the direction, B this direction. Then the current should be this direction. So think that current and voltage is 90 degree out of phase. So if so, then it is not only truly inductance, there is a resistance. So resistance current should be which direction? So inductive current is this direction. Resistance current should be same direction. Yeah. So what is the resultant direction? Between two, the resultant is what? Say this is the two direction. The resultant should be which direction? Somewhere in between the plane. Yeah. So it should be depending on the resistance value and inductive reactance value. It should be follow somewhere here. Yeah. Somewhere it depends. If it is inductive domain, then it will follow this. If it is resistive domain, it should be followed like this. Yeah. If truly inductive domain, it should be goes very closer to the inductive current. So depending on the value, it will vary this angle, but it is between 270 to 360 degree. This area. Yeah. This is the property of inductive reactance and resistance circuit. RL circuit. It simply said RL circuit. So think that now we can do the measurement that how much actually resistance and inductance, because whatever we are talking about voltage and current, what is the relationship between voltage and current? In terms of Ohm's law, it is resistance. Yeah. But here it is no more truly resistive volt current. It is actually the impedance, yeah, because it is neither resistive nor inductive. It is in combination of resistive and inductive. Then the pressure relation between here, see, V represents the direction of resistance, yeah. L represents the direction of inductive reactance. Then Z represents whatever the Z direction should be. Z represents the impedance. Cannot very difficult. So the thing is actually this is the direction of resistance. This is the direction of inductive reactance. Then the Z should be anywhere depending on the value of resistance and torque. You know the vector analysis, yeah? The vector will move which direction? It dominates someone. Say x-axis vector is 5 meter, y-axis is say 100 meters. So Z should be which direction if the Z is related to x and y? That means Z is equal to x, say in the positive direction, should be jy, yeah? So J say 100 plus I only. So which will be dominant here? Which will dominate? I is the real term, x-axis. The imaginary J is actually 100. So which will dominate? If you made it a magnitude, please do it. 5 and 100, x and y. Then Z value should be how much? Is the vector, all vector. Can calculate it? Z equal to x plus jy. So y is 100, x is 5. So Z should be how much? Say here we are talking about x is actually nothing but R, resistance. Y is nothing but XL. How much it should be the Z value? You know this because you did the mathematics, vector analysis. So any two vector, that is x-axis corresponding 5 and y-axis corresponding 10. Then the z-axis, the resultant vector, Z should be how much? How it should be calculated? It should be 5 square plus 100 square equals how much?
100.
Huh?
100.
10,025 over root. How much it is?
100.
100 something.
0.1.
0.1 or something. So think that it is almost Z and Y is similar, yeah? So it means that it will move towards this direction. Z is almost dominated by Z direction. Then how about the angle between the reference? How much it will be? This is truly 90 degrees, yeah? Whenever Z will move this direction, it is almost 100, means it goes this direction almost. So then how much the angle should be between the R and Z? Reference to the Z. Because it is R is not significant here, yeah? Almost inductive reactance is significant. Then the angle will be determined by the or lagging, yeah? So how much it should be? It's almost 90 degrees or close to 90 degrees, 89 degrees something. So this is the thing that determines the parameter, yeah? Now you can see that. So if it is not like this, the value is just opposite. Say Z equal to, say here is 60 plus 5 Z. Now see Z value how much it is. That means now in the resistive domain, resistance value is higher, inductive reactance is very minimum. Then how much the resultant value should be?
60.
60. Yeah, it is not 60, I think it should be 3600, yeah, 25, almost 60, yeah? 60 point something, yeah? 60 point something. Then again the angle should be how much? How to calculate angle? This is tan theta. Tan theta how to calculate? Tan theta equal to, say here is the XL. Here is the XL, here is the R. So here is the theta. So tan theta is equal to XL by R. So theta is equal to tan inverse XL by R. So now calculate both angles and how can you keep. So at the back, understand whatever I, because it's very small, I cannot make it very big here. It's better to come at the front. Why at the back? What is the reason behind that? Huh? It's very far. I even cannot see your face. So how you can see this? If you see that I am actually can see it. It is actually you are talking lie. Cannot see it. It's very far. So this angle actually determined by this, yeah. So think that we can measure angle, we can measure magnitude of Z between the value of L and R. So what we need to do, because we are talking here actually the very much intrinsic value, the integer value, yeah. But it should be not like that. It should be how? It should be say resistance value R equal to say 50 ohms. Say inductance value equal to say 20 millihenry. 20 millihenry, 50 ohms. Say frequency, supply frequency is say 60 kilohertz. Now calculate the inductive reactance. How much? XL how much? If it is 20 millihenry, the inductance value, and frequency value is 60 kilohertz. Supply frequency here is 60 kilohertz. Then XL value how much it should be? XL equal to 2 pi FL. So put the value 20 millihenry, milli, and this is 60 kilohertz. So then you should find the XL value. How much here? 75. 7.5 ohms. 7.5 ohms. Is it like this? So it should be like this. Think that 2 pi F is actually 60 10 to the power 3 into 20 10 to the power minus 3. So it should be 2 pi into 1200. How much it is? 7? 1200 multiplied 2 pi. How much? 2405. This one. So this is the value of this inductive reactance. The resistance is 50 ohms. So think that now it is actually inductive domain. Yeah? So depending on the value, because it is kilohertz, it is millihenry, so it will cancel. So 1200 multiplied 2 pi. This should be the inductive reactance value. Yeah? So this value will be which direction? This value should be this direction. So think that the vertical will be very long, horizontal should be very tiny, because we have only 50 ohms. So then it will again domain to the inductive reactance domain. Z should be along the inductive reactance direction. Yeah. So this is the analysis here, that how frequency will determine the domain of the inductive reactance. So if it is inductive domain, then the current should be current controlled by the how? Definitely current will be controlled by the inductive reactance, yeah, because resistance contribution is very minimum. Then drop voltage across resistance should be higher or lower, because current is almost, the impedance is here, almost all the value is here. Here is very less significant. Yeah, current will be dominated by the here. That is whatever the voltage here, almost drop here. Here is very little. Understand the point? Because if current is dominated by this reactance, it means that all voltage almost develop here. Very less voltage here, because current value is very minimum. but here resistance value also minimum. So it will develop voltage here. So that can make it parallel R, XL, Z. Then VR, VL, VS. The resultant should be supply, yeah? Because drop voltage here and here should be the algebraic sum of the voltage here. Every time it will be the same. Understand whatever I am trying to say? Okay, I just begin. Very difficult, very difficult. I think it's better to put some alcohol here.
Dapat
otherwise
7. Dapat 7. Okay, reading.
So everyone understand whatever I am trying to say.
Yeah.
Because before it was resistance, very simple, yeah? No phase difference, nothing. Everything is the same line, but now it is not like that. It is depending on frequency. We are talking about the magnitude of the inductance. But if you change the frequency, then again XL will be changed, yeah? The frequency and inductance, they are interrelated. If frequency change, then inductance will be changed. If the value of the inductance is same, still the frequency will be changed, the inductance value. Ultimately, the impedance value will be changed. Ultimately, the current value will be changed, because current is actually circuit current, actually determined by supply voltage divided by Z. So Z is actually nothing but R plus JXL. So think that if frequency change, frequency increase or decrease, then XL will be accordingly increase or decrease. So if so, then the impedance will be increase or decrease. If impedance increase or decrease, then current will be increase or decrease. Everything interrelated, yeah? Phase will be changed, voltage will be changed, everything will be changed. Understand what I am trying to say? Because this is the whole interrelationship. You cannot make it scattered, yeah? Even it is not fixed. Because it depends on the supply frequency, it depends on the inductance value, everything varies. So please try to understand it. If not understand, please raise your hand. I will try to explain again. So what will be the phasor relationship? The phasor relationship should be, think that this is the voltage or resistance direction. This is the inductive voltage or inductive reactance direction. So this is the supply voltage or impedance direction. I am talking about arbitrary because I don't know the exact Z value or, because if it is like this, the similar value of R and XL, then it should be make 45 degree angle, yeah? But if it is different, then it will be different. So think that either this is the R means actually it is VR, voltage developed across resistance, or resistance value itself. Then it is VL means voltage developed across inductive reactance, or inductive reactance value itself. Then it is the this voltage and this voltage algebraic sum is the, vector sum is the supply voltage. Every time, every instant it should be the same. The vector sum. Then this resistance and this reactance vector sum should be inductance, yeah? Sorry, the impedance. So this is the overall phase relationship. Voltage across resistance. That means it's better to write here VR, yeah? VR, voltage across resistance, or R itself, resistance itself, in the same direction. Then voltage developed across inductance or inductive reactance itself in the same direction. Then one thing we did wrong. Can you understand what we did wrong here? Anybody can? So it will be the current direction or inductive reactance direction. This is the This is the circuit current, yeah, the resistive current IR. What should be the IR should be which direction? In this direction, yeah? So IR is this direction, then the Z should be which direction? Capacitive current and inductive current is opposite. So this is lagging, the current here should be, capacitive current should be leading here. So this is ultimately the current direction. If you think about the direction of the vector, this is the resistive current, this is the inductive current, this is the capacitive current. So inductive reactance will be leading or lagging if current is lagging. Huh? Anyone can answer it? I think you did some. I did wrong, but nobody can answer. If anything say Z is lagging, so current should be on direction. Say Z for inductive reactance is R plus JXL. So this is definitely, it is plus, think that. So which direction it should be? If it is plus, say, so which direction it should be? Plus there should be which direction? See here? Yeah, this is the wrong thing actually. Sorry, I thought what I did wrong, I don't know. R should be like this, XL should be like this, IL should be like this. That is actually opposite, because the current will dominate for what? Voltage by IL. If IL itself lagging, then XL should be leading, yeah? Because it is reversal. So any angle 9 minus 90 degrees, so it will be resultant B I positive 90 degree, yeah? Because any lagging at the bottom should be resultant goes to the positive, yeah? Sorry, yeah, I think there was a wrong. Because it definitely it is Z plus. So definitely XL should be positive direction, not negative. Yeah. J, if anything like that, the J is actually positive. J positive means it is coordinated toward the leading, yeah?
Yes.
XL leading, but current is lagging. That is the wrong. Actually, I did. Current will be lagging, but inductive reactance will be leading. Then resultant impedance should be leading. Yeah. The XL circuit, this should be the direction. Sorry, I am sorry because I forgot to analyze either XL or IL itself. Once you write this is positive, that means it is actually positive direction, 90 degree leading. Impedance leading, current lagging. Because the current is nothing but voltage by impedance. So impedance leading means current will be lagging. Current should be downward. Any angle of the impedance, if you make it say it is 45 degree, 45 degree, so minus 45 degree or plus 40, definitely Z is 45 plus, so V by Z, it should be minus 45 degree. It means that current will be 45 degree lagging, whenever impedance itself is leading. So this is the relationship between leading and lagging function of this vector. Sorry, yeah, because this should be the impedance, inductive reactance should be leading, inductive current should be lagging. And this is major problem, inductive current lagging, it is major problem in the industry. Every industry, chemical industry, electrical industry, everywhere. What is the problem? I will discuss it. I have the video, I will transfer it to you. The problem is inductive current lagging, actually the current flow through the power line, it is always tends to be make high power, current and voltage should be same phase. But if it is lagging, then it is not in the same magnitude, yeah? If it reduces, then the supply company, say SESB in Sabah, they need to flow much more current through their line. So much more current flow means their line drop should be high, line power loss should be high. If you are responsible to flow to force them to flow extra current, they will charge you extra. Your company, your industry will be charged extra. And that is called the power factor charge. They do it normally. That's why at the industry level we try to make it inductive reactance is the most of the motor, everything is inductance, yeah? This is properly like this. You know, motor, generator, fan, everything actually, even your exhaust fan, everything has lot of windings, yeah? That is actually this inductance. So there should be current lagging. Then the lagging current to supply extra power from the supply system, they will charge extra because extra current flow actually make extra loss, heating loss in the system, in the line. So how to do it? Then we have to put their capacitor bank. That capacitor bank will make it capacitive reactance higher. So the adjustment of the inductive reactance and capacitive reactance that can make the minimize the current leading or lagging, yeah? That eventually make resistive domain current. That means same direction of voltage and current. That will, because power is not only voltage, neither voltage nor current, yeah? Power is the multiplication of voltage and current. So if current is lagging, then resultant current will be less, yeah? So this is, say this is my hand. If the sun is at the top, then its shadow should be all the length, yeah? Is it not like this? If your hand is like this, then shadow should be hollow. Reduce or decrease or increase? From reference to this, it will increase or decrease?
Increase.
Decrease. This, more decrease. This,
Increase.
no shadow, yeah? Very small pointed shadow, yeah? So something like that. If your current is lagging like this is no lagging, yeah? If this is lagging, then no current. That means it cannot flow any power. So you should consider that the current should be in the same direction as voltage. To do so, you have to make it capacitor bank, something like that. So I think you understand the RL circuit, yeah? Whatever I am trying to say, the inductive reactance and capacitor. Because sorry again, yeah, because whatever we do analysis at the fourth coordinate, that should be sit in the first coordinate, yeah? Because XL should be first coordinate, impedance should be first coordinate. Not only because I feel that it is the current that should be in first. So this is one part. Now it is actually, I am telling again that if anything you say that it is positive, J positive means it is actually first coordinate. Yeah? Then how about the capacitor? If we put here a capacitor, then what should be the property? Here must be ground here. What should be the property now? Now you should follow this. So what should be the property here? Xc, capacitive reactance should be 1 by, think that it is inverse. It is inverse. Frequency increase, capacitive reactance will be increase or decrease? Definitely decrease. So I say it's the fact, actually the theory behind it. Because capacitive reactance, whenever we apply voltage, the voltage across the capacitor actually induce the electric field first. And due to the electric field induction, it just opposes the voltage to current flow or charge flow through this. So it means that instantly the current flow is maximum through the capacitor. At when it's turn on the switch, the maximum, then gradually develop field across capacitor, it cannot allow to flow current. So what is the relation between current and voltage now? Initially high current, then gradually decreasing current. So current is actually leading here. Voltage respected, current is leading. But how about the inductive reactance? Inductive reactance instantly it is looked as a what? Lens law. Please follow the lens law. It is the highest maximum voltage opposite. Yeah? That means no current flow initially. In course of time, it try to flow current. That means the reactance is initially high, then gradually decrease. That means their current is lagging. Because initially voltage developed, then after reducing voltage, current can flow. So current is lagging with respect to the voltage in inductive reactance. In capacitive reactance, instantly current is higher, then it develop the voltage across capacitor, then current is decreased. That means in capacitive reactance, voltage actually lagging. current leading. Capacitive reactance case, voltage lagging, current leading. Inductive reactance case, just opposite, current lagging, voltage leading. Yeah. I am talking about VL, I am talking about VC. This is the relationship, the physical relation of the capacitor inductor is like this. So if so, then the thing is here, the circuit theory, here the phasor diagram, see that once the current is leading, current is lagging here, inductive reactance, then definitely inductive reactance will be leading, reference to the voltage. So impedance will be leading. That is the relation of inductive. So how about the capacitor? Think that the capacitor case, actually, here what I am talking about. Here, if we talk about that, the voltage is reference like this. This is the voltage, resistive voltage. So, then here current is leading. Current leading. Capacitive current leading. So, capacitive reactance should be lagging. Yeah. This is the relation. Yeah. So, if capacitive reactance is lagging, here resistance is reference. So, RC circuit, that should be follow this 4th coordinate. Yeah. So impedance should be like this 4th coordinate. Yeah? Just opposite. Yeah, before I talk actually wrong. That was the wrong. So what should be the parameter? The parameter should be here was Z equal to R plus JXC. Here should be Z equal to R minus J. So think that it is actually 3rd coordinate. So it should be minus J. Yeah. Think that here minus should be minus J. So minus JXC means this direction. So it will eventually get here, the Z should be this direction. So this is the relationship, vector relationship. So what we can say, here VR, R, here is VC, XC, yeah, this is should be then, here should be VS or Z, something like that. Please try to understand, then I will actually upload my video. Yeah, then you can understand. I have the link. I will send it to you. The phasor relationship is very important to analyze for the AC circuit analysis. So can see at the back because it's very difficult. It's very messy. Yeah? But the problem is it cannot erase. The red can see at the back, but the problem is red cannot erase here. That is the problem. Even using water cannot. I don't know why they choose this type of whiteboard that cannot erase the red color. So this is the ultimate RL and RC circuit. Yeah? Now no more RL, it is RC. RC, yeah. This is resistance. Now think that here is 50 ohms, here is 60 kilohertz. So same frequency. Now capacitor value is say 20 millifarad, very high, yeah? Microfarad. So how much is that? So 200 microfarad. No, 20, 200 microfarad. So now calculate the XC, how much? Capacitor value is 200 microfarad. Frequency same as 60 kilohertz. Then calculate the value of capacitive reactance. I don't know what they are doing on the back, how they are doing it. Try to do it, yeah, because we don't have enough time already. Yeah. Is it the 9-8? So what we are doing? X equal to 1.3. Huh? 1.3. 1.3 ohms, yeah, very minimum, yeah. So think that before for the inductive reactor, same frequency, it was very high value. Now for capacitive reactor, it is very minimum. So now is resistive domain, yeah? So our Z value should be how much? So Z value is 50 minus Z 1.3. How much it is? How much the value should be? You should calculate both the magnitude and phase angle as well. So definitely it should be this for A, so it should be negative. Yeah? Please calculate the value, angle as well as magnitude. Any phasor term, actually there is two parts. One is real value, another is imaginary value. So please calculate its magnitude and angle as well.
Lagi 1 jam. Lagi 1 jam. Tahannya.
R, VR, XL, DL. Yeah, it is DS or Z. Yeah. And then here it is RL, it is RC. Yeah. How much the value? Almost 50, yeah?
Yeah.
50 then?
50.01.
5101.
Yeah.
So if so, then the angle should be how much?
Mm,
That means it is truly resistive domain. So how much the angle? That means 1.3 divided by 50. Inverse 10. How much? 0 almost, or 1 degree. Something.
0.02.
So it is insignificant, yeah? That means all is resistive current, yeah? That means all voltage will drop across resistance, yeah? Here very minimum voltage, almost 40. For this particular value of capacitor and particular value of. So now you change it, say it is 10 microfarad, then how much it should be? Say this is 10 microfarad, no more 200, it is 10 microfarad only. So how much then the value should be? So angle actually whatever you get 0.2 or that is negative or positive angle. For the Z it is negative, definitely negative. It is fourth coordinate. It should be negative. So current should be positive. If you make this reverse, then 0.2 is the leading actually. Now it is 10 microfarad. Then how much the value should be? Capacitive reactance. Same frequency. We are not changing the frequency. 10 microfarad. Before it was 200 microfarad. That means it will be 20 times increase now. So before it was 1.3. Now it should be 26 ohms possibly.
Yeah, 26.
So if 26 ohm, now you can see that this is almost a part of significant 26 ohm. So if so, now you calculate the Z and angle again.
Kaya ada orang dapat patut memang
Please
macam
forward
ni
back,
26
otherwise it will be impact in your mid-term and final exam as well. This circuit analysis. So be careful about that. And we have no alternative time. We cannot make it repeat again. Because we only have 5 weeks left. 5 weeks, there are a lot of courses still have. Five or 6 weeks left. I don't know how we can make the presentation here without instructions. Please complain to the office, yeah?
online.
Online.
Only online complaint.
Online.
Yes.
I can contact online, but this is actually not very. Sometimes such interaction I cannot do, yeah? And you don't have the alternative tutorial time. That is the problem. So how much now? Z value how much? For the 26, for the 10 microfarad, then Z value how much?
Wait, so it's 56.
56. 56, then angle? The lagging, definitely lagging. So how much is that? 26 divided by 50, cos inverse, tan inverse.
0.4.
No? It should be around 45 degree or 40 degree or something. See that tan inverse, here should be 26, here should be 50. How much is it? $49, $48, $46, something like that. Oh, it's very easy to calculate from that.
Wait, sir.
Hey, go and eat long time. Just tan inverse we put 26 divided by 50. 26 divided by 50, then make it tan inverse. Angle how much? 27. Yeah, whatever it is, I don't know. If that means 27.47 or 5, yes. So think that if Z is value there, then the circuit current should be how much? So it is 0 reference voltage supply. It should be V by 50. V value we don't put here, any value you can say. Then it should be positive 27.5. Because now already up here, negative go up. So something that relationship is like this, yeah? RL and RC circuit relationship is like this. Phase relationship just opposite. Capacitive reactance and inductive reactance is opposite. Then capacitive current, inductive current is opposite. Here it is changing, think that it is changing with course of voltage. It is changing with course of current. Here is variation of voltage with variation of current. Here variation of voltage with variation of current. Current variation make voltage variation make current. Here current variation make voltage. Because inductive property is actually magnetic property. Magnetic property actually current domain property. Current variation can make magnetic. You heard about Ampere's law. Ampere's law. Ampere's law dealing that the current variation can make magnetic field. Ampere's law, Faraday's law actually interrelated. Then Gauss's law, Coulomb's law interrelated. Yeah. Then interface between the Ampere's law and Faraday's law, there is Lenz's law. That is actually determined. So this one actually be careful about that. The variation of current can make voltage variation in inductive circuit. Then variation of voltage can make current variation. Why variation of voltage here? Because capacitor is actually electric field domain. So electric field means actually voltage. So voltage variation only can change the current flow through the capacitor. If there is DC voltage, then is there any change with time? No. Definitely no change in time. There is steady current. So what value should be IC? If you set a DC circuit, a capacitor, what value should be the capacitor current? Say here, if frequency for the DC, frequency is how much? Frequency for DC is how much? 0. If 0, then reactance should be how much? Okay? This is major problem. If everything the reversal is 0, then the value should be how much? Anything divided by 0 is how much? Value? Infinity, definitely infinity. So x is infinity. So x is infinity means current should be what? Current should be definitely 0. So no time change of current, that is no current. No time change in voltage, that means it is current 0. Then here, no time change of current, that is voltage is 0. That means if you apply the DC voltage here, you will not see any voltage develop across inductance. If you actually connect DC supply with the capacitor, how much the voltage should be there? The maximum voltage, because the reactance is the infinity. So all current will be, all voltage will be drop across capacitor reactance. So be careful and be clear concept about that. How actually it gets frequency variation with the inductive reactance, capacitive reactance. Frequency 0 means capacitive reactance is highest, infinity. Frequency 0 means inductive reactance how much should be? XL should be 2 pi FL. So how much it should be? Frequency 0, inductive reactance should be how much? Definitely 0. So if you apply the DC, you will not see any voltage here. Then if you apply DC here, you will see the maximum voltage here. Because no change in reactance, the highest reactance value. That's why you cannot apply the capacitance in DC supply. You can, but it will be stacked voltage. It will make as a fixed voltage as a DC supply. Same. It cannot allow to flow any current. So why I am discussing, because it should have some impact in your assessment, in your exam. So please be careful about the analysis of capacitor, inductor, capacitive reactance, inductive reactance, its phase relationship, its current flow relationship, its magnitude and angle variation in the system. Then how the variation of this capacitive reactance with the current variation for inductive voltage, with the voltage variation for capacitor current. So if you understand, so anyone, I will ask you to come here and discuss this matters here, this today. Because this part is very important, because it seems to be a AC circuit analysis as an independent parameter, but it is not independent. Whenever you talk about the motor, generator, alternator, everything, that is actually that. The inductive reactance are there, capacitor are there. So how they make impact on the frequency variation, it should be understood. Yeah, we are not going that level because it is actually third year electrical engineering student course. But you are learning it as a second year non-electrical engineering course. So we are not moving that complex area. But still you have to know it. I think I finished my discussion. Now you should discuss. Student discuss, anyone discuss it. Yeah. Who want to discuss it? If you understand, it is very easy to discuss. Today who will willing to discuss this matter? It is truly mathematical analysis here, vector analysis. So please stand and make it confirm and then someone come here to discuss, yeah? It cannot be a abstract concept, yeah? It should be clear concept. That is important. So who will come today? Come someone, yeah? I will assist you or discuss here in the blackboard. Why? So I again explaining, yeah, because say this is the RC, there should be a shadow RL. Yeah. So RL and RC. This is ground, this is L. So the same supply here should be follow this. This is the RL circuit. This is the RC circuit. How it gets? The fundamental relationship of inductance is it follows the Lenz law. The Lenz law means any changes that happen inside the circuit, they don't bother it to change. They just make obstruction. So any current flow change, it makes reverse voltage. So it means that it develops voltage first, then the voltage eventually can allow to flow current. So it means here voltage is leading, current is lagging. So current lagging means current lagging is 90 degree lagging with reference to the voltage. And then voltage leading means this direction. So voltage inductive reactance should be leading reference to resistance. So impedance should be first coordinate in inductive circuit, yeah, RL circuit. This is the first concept. Then how about capacitor? Capacitor is, it is actually a electric circuit. So electrostatic field, always think that it initially at the time it offered 0. So think that frequency or time, it is actually 0 time. 0 time means actually frequency time 0. So it means it does not offer any reaction. So it allows maximum current flow initially. That means it actually current leading. Then eventually here develop a magnetic field. Electric field. Then electric field then discharged to flow current. So that means here current is leading, voltage is actually lagging. So this is writing here that voltage lagging, current leading. Here is voltage leading, current lagging. In that sense, actually, if current leading, so current should be forward direction. Then in that capacitor reactor should be lagging, or voltage should be lagging. So in that sense, it should be the reactance coordinate should be the fourth coordinate where Z will cover. So Z eventually it is lagging. Here Z is leading. If Z leading, then current should be lagging, because current is nothing but resultant current. I am not talking about inductive current. Resultant current. Resultant current should be lagging. If impedance leading, current should be lagging. Just reversal, because current is nothing but voltage divided by impedance. If something impedance is leading, then current will be lagging. That is the relation of reversal, current and impedance. Impedance leading, current lagging. Impedance lagging, current leading. Here is impedance lagging, current is leading. I am not talking about capacitor current, I am talking about resultant current. Resultant current should be this direction. Here resultant current should be this direction. IS circuit current, IS. Or IC, whatever you say. But IC you cannot write because IC itself is capacity current. Yeah? So this is the phenomena of understanding. Then whatever you want to calculate, it depends on your value. Your inductance value, its frequency, that will determine your inductive reactance. That eventually make your parameter of impedance and parameter of leading or lagging factor. Because capacitive reactance follow this relation, inductive reactance follow this relation. So if the value of inductance and capacitor you know, if you know the frequency, then you can easily calculate the reactance value. Then reactance value determine the inductive case, it should be J operator positive, that means it is leading. Here should be J operator lagging, that is actually lagging. That means here actually Z is equal to R minus JXC here. It is R, it is X. Something like that. So I just reshuffle again or illustrated again. So now anyone can willing to discuss. Come someone. Because as long as you cannot respond, I cannot understand that you understand it.
So I still don't understand the calculation.
Here. So please make it. Here is 2 into 3.14 into F is 60 into 10 to the power 3. This is 60 kilowatts. Then it is 10 into 10 to the power minus 6. Now do it calculation. If the previous calculation is right, that is 1.3, then it should be 26. Because before it was 200 microfarad, that means 20 times, now it's smaller. 20 times smaller means the reactance value should be 20 times higher, because it is actually 1 inverse.
But I got 0.26.
0.26.
Yes.
If so, then the previous was wrong. They told me 1.3 ohms.
The previous one is 0.0132.
So, but they said it's 1.3. What?
No.
If said 1.3, then it should be 26. If said 0.013, then it should be
0.26.
0.26. Yeah. It depends on your value. I don't calculate. I never calculate it. I reference to your value. Whatever the value you put, that should be exactly the relation like this. So be careful about the calculation. Yeah. So if previous calculation is wrong, that it is not 1.3 ohm, then it should be wrong. Lecture and tutorial together, because we only have one lecture in every week. That is, we know alternative. So now anyone can discuss. I expect that someone will come and discuss in favor of the students. Yeah. Who can?